Hi everyone, this is the first lesson in chapter 2. We're going to be solving linear equalities throughout the whole unit. Right now, we're going to start in section 2.1, which is an intro to inequalities. In our first chapter, we were working with equations. Equations meaning using an equal sign, completely the same. But we're going to see that inequality symbols, while similar to equations, also have some differences. So let's take a look at just an example of an inequality, what we might see in real life, or something that we might say to somebody, you know, my age is at least 30 years old. So if I was just going to ask you what values would make this true, how old could I be? You might say, well, you could be 35. That's at least 30. Or could be something maybe much larger, maybe 65. It could be a decimal in this case. It could be a fraction. And the idea here is there's not just one right answer. There's actually a multitude of answers. In fact, an infinite number. And because there are so many answers or solutions, another word for that, we're going to look at representing things algebraically as well as graphically. So how do we represent things algebraically? Well, first we identify who's our variable. In this case, our unknown is my age, which we can I'll just do X. And we have a comparison here. My age is at least 30. So we're comparing our age to 30. So I wrote those two values there. And then I'm trying to decide what sort of symbol I'm going to use. So I want you to look down here. There are 4 basic inequalities, and the symbols are right down here. We are going to learn the names of those in a minute. But for this case, hopefully maybe you have some familiarity with inequalities, or at least can start to feel out which symbol we're going to use. So is at least, my age would be X. It would be greater than, for sure. But because we say at least 30, we could actually end up equaling 30. And so we put this little line underneath that inequality symbol. If we consider some of the answers, some of the solutions that we were thinking about in the beginning, and we substitute one of them in for X, you would notice that we would come up with a true statement. 35 is greater than or equal to 30. And that's how we know that algebraically what we've written is correct. At least that's how I double check how I'm doing. If I have my symbols in the right spot, I just always pick a number to substitute it. So what are our 4 basic inequalities, basic inequality symbols? We'll take a peek at those. The first one we're going to start with is the is less than symbol. You could also say is fewer than. And so when we say X is less than A, what we have on, if we consider a picture of this solution graphically on a number line, we have some value A. Could be negative, positive, decimal, integer. Okay, and the X's are smaller than A. And on the number line, numbers that are smaller than any given value are to the left. But X cannot actually equal A. Like up here, the X could equal 30, but X cannot equal A. And so what we do is we use an open circle over that starting value to indicate that while the X's can't equal A, they begin right after that value. Or we could have less than or equal to. This graph looks very similar to what we just graphed. We have our A value, and we'll be shading to the left. But instead of the open circle, we will give a closed circle because in this case, the X's could equal A. And that's why we want to shade in that circle. There are many different words that can be used for the is less than or equal to symbol. Obviously, is less than or equal to, but one of the other sort of words you can say is at most. So if something, you can be at most 54 inches to ride this ride, you have to be less than or equal to that value. Another synonym there would be maximum, right? This is the maximum value. And then finally, another one would be is no greater than. Again, we have that negation argument there, that no greater than. And so that's turning into a less than or equal to. On the flip side of things, going back to our warm-up, we have x is greater than a. So we have some value a. On the number line, numbers that are larger are to the right. And again, because x cannot equal a, and again, how do I know that? There's no line underneath it. See, that's the equal to or equal to line. I'm going to leave an open circle at that a value. So again, this is more than or is greater than. And our final symbol, x is greater than or equal to a, which is what we had up here in our warm-up. So we have that a value. This time we shade in it because we could equal our starting value there. And again, we shade to the right. So is greater than or equal to. So instead of is at most, we could have is at least, which is what we saw in the warm-up. We could also have minimum, or is no less than. So again, lots more options for the is greater than or equal to, or the is less than or equal to. So these are our 4 basic inequalities. Like I said, what we're going to be doing is graphing them, writing an inequality from a graph, and then also what we did in the warm-up, representing things algebraically, doing some decoding. Now we also have 2 compound inequalities. So think back to English class. A compound sentence is linking 2 thoughts or ideas or sentences together. So a compound inequality links 2 inequalities together. The 2 types of compound inequalities are the and inequality and the or inequality. Okay? The and inequality can also be written as one joint inequality. I kind of like to think of it as like an Oreo cookie because you have the x, your variable is like the cream in the middle, and then you have 2 values above and below. So these ones graph out similar to what we just looked at, except for we're going to actually have 2 inequalities at the same time. So let's take a look here. X is greater than a and x is less than b, excuse me. So we're going to put a here on the left and b here on the right. And I want us to think about this for a second. So x is greater than a. If I would graph that, that would be an open circle shading to the right. The x's are greater. And x is less than b. So if I graphed that inequality, I would have an open circle at b, and I would be shading to the left. So right now, it looks like the entire number line is shaded. But what I want us to pay attention to is this key word and. And means you have to be both true at the same time. So something has to be bigger than one value, but smaller than the other at the same time. And so if I was a number out here in this orange shaded part, I would certainly be bigger than A, but I wouldn't also be less than B. So what ends up happening in this inequality is just the in-between portion of A and B ends up shaded. So now I'm going to erase this so you can see what's going to happen. I don't usually graph both at the same time and then erase them. Usually I just sort of think what is happening. And another way, again, I think of this is the Oreo cookie sandwich. This is like X is in between, right? That cream is in between the cookie. And so we're shading the values in between A and B. The second type of compound inequality is one where we have an or. And when we have an or, you don't actually both have to be true. So, this is students who play basketball or tennis. So students that play basketball, good. Students that play tennis, great. A student that plays both basketball and tennis, great. But one or the other could be true. And so what's happening here is we have a value A, X is less than A, we would shade that. And then we're going to have a second value B, where X is greater than B. In this case, since we don't have to both be true, both inequalities are graphed kind of on the same number line, but considered separately. Because we cannot be on this side and that side at the same time. We can be one or the other. So these are the basic type of inequalities that we're going to be working with. Let's take a look again at some graphing. So let's look at these 4 inequalities that we're going to graph, and then I'm going to have a part 2 of the video. So graph each inequality below. B is less than -1. So we find -1, open circle. The B's are smaller, and we're going to shade to the left. If I am just kind of thinking, is my shading working out? All I do is I kind of go over here and I pick a shaded number. I substitute it in for B, and I ask myself, is this true? Is 7 less than -1 true? Yes, it is true. So I did shade in the correct values. So if you ever feel like you need to double check your shading, make sure things are going correctly. This next one, H is greater than or equal to 8. So because I can equal 8, I'm going to fill in that circle. Numbers that are larger than 8 go to the right. Our third example, we have that compound, and I'm going to pull that back up. Again, X is greater than A and X is less than B. So in this case, the X is greater than, I know that looks like a less than sign, but it's because it's in the middle. If we write 1.5 is less than X, we could also turn that around and say X is greater than 1.5. So the X's are larger than 1.5. At the same time, they're also smaller than 5. Okay. We cannot equal either 1.5 or 5, so I'm going to put an open circle at 1.5 and an open circle at 5. And again, the X is in between these values. So let me show you how, again, you would pick a solution value to make sure this is true. If I pick, let's say 3, is 1.5 less than 3? Yes. Is 3 less than 5? Yes. Again, the 3 goes where my X goes because that represents all values in between 1.5 and 5. I also failed to mention up here, to be honest, that you could also have less than or equal to's here, a combination of 1 just less than, 1 less than or equal to, something like that. I just didn't want to write 1,000 different combinations on the notes. And our last graph that we're going to look at is an or statement. X is less than or equal to 22. So close the dot at 22, shade toward the left. Or my other option is X is larger than 28. Open circle at 28, shade to the right. And that's what this graph looks like. At this point, I am going to stop this video, and you're going to have to watch a second video to get the rest of the notes.